Okay, so this video is basically a lesson video of lesson 15, which is going to be long division of polynomials for anyone who is not in class right now or anyone who is in class for this lesson and needs to supplement it a little bit. One thing I just had on the board is kind of a recap of where we've been. We did in lessons 7 through 11 factoring methods 1 through 5. We solved polynomial equations. We graphed polynomial equations. We wrote polynomial equations from a graph. And now what we're doing, so this is where we left off. Now what we're doing is we're trying to get ourselves to this, factoring method number 6, rational root theorem. The reason we need something like this when we get there is when we try to factor something where none of the factoring methods work. Grouping doesn't work, GCF doesn't get us anywhere, it's not a sum or difference of cubes, it's not a difference of squares, we can't use AC method, none of those methods work. Well, there has to still be a method to unfoil something, right? Like, if you had foiled or distributed or expanded to make it, there has to be a method. It has to exist to go the other way, right? To go backwards. But what is that method? Now, what is foiling or distributing? What mathematical operation is that at the heart of that? What are you doing? Multiplication. Right, we're multiplying. So that means if you're multiplying to create these polynomials, well, factoring is going to involve what operation to go backwards the other way? You're going to include division, exactly. So before we can do this factoring method 6, for lack of a better phrase, which is known as rational root theorem, some books or teachers, tutors, they could also interchange. Sometimes you'll hear rational zero theorem, something like that. Most textbooks I've looked at have called it this, so I tend to call it that. You'll see we kind of have two little lessons coming up in between before we can get there. And what are they? Division, right? So we are today going to be looking at the long division of polynomials. So I have a couple little warm-ups for us before we can get there. Hopefully this is all a really good memory jog. Even if it seems, I know sometimes it seems very easy, silly, why are we talking about it? But it's been a while since you were in 4th grade. It's been a while since you did long division that you learned from your lovely 4th grade teacher. And it might not be a bad idea to revisit that entire process, right? So let's look. What if I'm going to start with, before I do this even, what if I asked you to use long division to divide 145 by 3. Do you remember what long division looked like? What the symbol looked like? How you set it up? What do you remember about it, Estelle? Right, so we started off kind of like this, exactly, right? Now, it kind of looks like a square root symbol. It is not a square root symbol, so don't put that little, hook on it. That would make it a radical. I'm going to come back to this in a minute, so I'm just leaving it on the side. But that's how we start. Now, even though some of you might be able to do this right now, you might not necessarily talk through it. You might not use all the right vocab. Pretend for a moment you had to help a 9-year-old cousin, neighbor, somebody, your friend's brother or sister, your brother or sister, with their long division homework. They were absent for school, they don't know the lesson at all. Do you think you could explain or teach a 9-year-old how to do long division? Do you think you remember? What would you tell them to do first? Isabel, you remember? Oh, okay. I like that. How many of you would have said, how many times does 3 go into 14 right away? So people that say 14, you are totally correct when you're doing it yourself, but I like that Isabel said she would have tried the 1, because sometimes you try that first digit and it works, right? Like, what if that was 745? So when you teach a little kid, right, you don't want them to think that they just start with the first 2 numbers every time. So I did like that Isabel added that little extra something over there when she mentioned the 1. Now, does 3 go into 1, Isabel? No. So that's why those of you who raised your hand about the 14, you know, your brain already was like fast forwarding and like, okay, let's get to the point, 14, right? But let's pretend, because zeros and ones always screw you guys up, and they're going to come up in this long division of polynomials. Let's pretend that we did this with zeros in place. So how many times does 3 go into 1? 0 times. After you write the 0, what do you do with it? Like, if it were any other number, what's the next part of the process, Trinity? Good. And what is 0 times 3? And where do we put that? Yes. Under the digit we just used, which in this case is the 1, right? So I wrote it under there. We are doing excellent. What happens next? You wrote it underneath. I know it's normally not a 0. What else happens? Go ahead. Right, you subtract that. In this case, we get that stupid 1 again. That was useless for us. But what's the extra little thing we add in here? Go ahead. Right, we bring down that 4, and that's that 14 that some of you kind of started with. So it doesn't matter if you start with the 14 or if you start with the 1. You do get the same answer, but for the sake of detail and clarity, you know, I want to go through each digit. So now we do the same process, right? So it's sort of cyclic. You did 1 divided by 3. We got 0. We wrote it here. We multiplied it there. We wrote it there. Subtracted, brought down the next number. Now we go back to the side, repeat. What's 14 divided by 3? What number do we get, Sam?
I mean, we get 14 4 times.
Exactly. Good enough, right?
Also,
yeah.
My whole life, I've never done that first step that you did. Like, if I see that 3 doesn't go into 1, I just lose off.
Right. Yes. But the reason I'm bringing up the 0 is because when we have polynomials that we're dividing, which are going to look like this, you're going to have to put zeros in sometimes. And that was a step that probably even in 4th grade, your teacher was like, oh, it doesn't go? Okay, move over. But low-key, secretly, what was going on behind the scenes, that I just did. She or he just didn't have you write it down. Because there are more important things for you to learn when you were 9, right? Like, they were like, all right, let's keep it moving and go through it. So I just point that out. No one really does that. But when we have the polynomials, you might need it in certain places. So that's why I want to show it. But now we have that 14, and when I asked what's 14 divided by 3, Sam like really, you know, emphasized, rephrased his answer. He's like, well, 3 goes into 14 4 times. So what are you saying when you say that?
You have I'm not 3 goes into 14 4 times.
But 14 divided by 3 is not 4.
14 divided by 3 is not 3. So you have to subtract 3 times 4, which is 12, from 14.
And what is that 2 from 4th grade time?
What?
When you were in 4th grade, right?
Yeah.
And you talked about that other 2. Like if this was just the example, 14 divided by 3 is 4. How did you divide when you were 9? Like even before long division, do you remember how you dealt with these like random numbers that were? Anybody remember what you called like the extra amount? Yeah, remainders, right? Remember it was like 4, remainder 2. Does that sound familiar? Yeah, that's what you're trying to get at, right? Yeah, I was just looking for the word remainder to see if you remembered it. So 4, remainder 2. So, all right, 4. I put the 4 up here. 4th grade style, maybe 4, remainder 2. What do you do with the 4? Same process, right? What's 4 times 3? That's the 12 Sam mentioned. Subtract it. This is what he kind of talked us through. And we get that 2, that leftover amount. But what do we do next? Right? How many times does 3 go into 25? Oh, we got everything. I just heard 6, 7, and 8. 8, let's see what's 8. What's 8 times 3? Ah, beautiful. Subtract 1. What happened after this in 4th grade? What happened? A couple different things may have happened, so Caduce was one thing. Is that what you guys were going to say? Yeah, so a lot of you might remember that. You bring down the 0 and you make a decimal. What about the route where you kind of think of it with the remainder? Do you remember writing this answer another way? So instead of it being, say, like 48 remainder 1, right? 145 divided by 3, which is the same as 145 over 3. How else? Trinity, what do you remember? Ooh, so nice, right? 48. I'm going to write the words she said, and 1/3. You guys remember that language? 48 and 1/3. But did you write it with the word and? How did you write it? Right. And do you know why that makes me so angry in life? That they have you write it like this in 4th grade? Why does that make me sad? Right. In high school, when you start sticking numbers next to each other, exactly, it's multiplication, right? But what operation is this really representing in elementary school? Yeah, that's actually addition. Now, one other thing before we do this other warm-up piece, so for part 1 of our lesson today, before we do the long division, just going to grab a little scrap paper here. One big thing that for some reason everybody remembers learning in 4th grade is, do you all remember learning, first of all, what type of number is this? Do you remember what it's called? Mixed number. Do you remember learning, how do I change a mixed number into... Yeah, I heard we multiply. Like, you already know the process before we even have to say what it is, right? So improper fraction. How do we change a mixed number into an improper fraction? One of those things. Right. You did 48 times the denominator 3. Add it to that numerator. So that will be 144 plus 1. 145, and then what do we do with that? Oh, I'm off the screen. And say that the last part again? Yeah, we keep it over that 3. Right? Everybody remembers how to do that? Yeah. It's like that thing that it's like, you learned that, and that stuck. Why does that work? It's like the one thing everybody is so amazing at from 4th grade. But why does that work? What are you doing? Who was your 4th grade teacher? What was her name? Miss Levine? Miss what? Jackie? Yeah, I love her. Because Miss Levine and Miss Jackie said so? What was your teacher? How do you forget? Yeah, 4th grade. Senior? Mr. Hart. So because they said so, that's why it works. The teacher was like, oh, guys, I'm going to teach you this thing, how to change mixed number to an improper fraction. Ready? Secret sauce. 48, you multiply it by that, add that, and just keep it over that. And you guys were like, okay, done, right?
In 4th grade, at least in my 4th grade, we weren't allowed to do improper fractions. Ever.
Oh, man, improper fractions, those are where it's at in high school.
Yeah, well, in this school, but not in my elementary school.
Yeah, in elementary school, I don't think kids understand how big numbers are at that point when they're improper.
We just weren't allowed to, if we did that, then we got points off on the test because it wasn't complete.
Oh, no. You survived.
I did survive. I did survive.
But let's just chat about how this works, why this works. Ready? What did we just say? Trinity told us this number out loud. What did she call it? How do you say that? The whole mixed number. How do you say this number? 48 and 1/3. And you guys just told me the word and means addition. How do you do this in high school? Lesson 2 of this course. Arithmetic with fractions, right? How do you do this? Go ahead, Caduce. Start with 48 over 1. Then, good. What is the least common denominator going to be? How do I help the 3 situation over here? And? No. Don't you have to multiply top and bottom by 3? Right? Okay, now I have a common denominator of 3. So you did 48 times 3, which is 144, plus 1, they're both over 3. So we got 145 over 3. So when you did your 4th grade magic trick, you were adding a whole number and a fraction. When you were doing the whole number times the denominator plus the numerator, you were secretly just doing this without doing this, right? A lot of the little tricks that you might know and might use are all backed by math. Otherwise, like, they're not really just tricks. They don't just work. There's math behind it, right? Question. Yeah, it's always going to work that way because your denominator for the whole number is always 1, right? So whenever you find that common denominator, you're always going to multiply the whole number by that to get the common denominator, plus that other numerator when you have those common denominators. So that little shortcut works every single time, right? Now, when we do division in this class today, you're basically going to have a problem like this, but it's going to be a polynomial over a polynomial, right? We're going to divide it, and we're going to get an answer kind of like a mixed number. We'll have our quotient and maybe a remainder over whatever we were trying to divide by. But you can't just smush them next to each other. We put them together with a plus sign. That's the way we write a mixed number using not just digits, but polynomials. Okay? So we need to be able to practice on something. So let's do an example, kind of linking back to lesson 14. In lesson 14, you were given a picture, right? And I asked you guys to write equations from the picture. Can everybody tell me what the factored form would be for something like this? What would the factored form be for something like this? Go ahead, Trinity. Good, because that gives us -3 as a 0. Times x plus 1. So these are 2 factors. Factors are things that we multiply. Yep. So you have it on the packet in front of you too, right? So it's on the next page, right? So you don't have to strain your eyes, sorry. It's right there, right? So it should be that packet you guys have, right? So that's factored form. This part, done. How do we do standard form? Question, go ahead. Yeah, you want her to get, is she there, you're saying? If you want to check and see if there's anyone there to give you Advil first, want to try that before, and get some water too while you're out? And then we'll figure it out from there. If anything, you could just listen and watch the recording later, you know, when you feel better. Okay, that's factored form. Leave the door open while you, how do we get the standard form from there? How do you get the standard form? What do we remember? I know we were on a break, but Lucas? Sure. Which two do you want to do first? How about, want to do these two? What do those FOIL act to give us? Good. Outer is 1x, inner is 3x, so plus 4x, plus 3. And we still have that x minus 2. And then how do we finish this up and get it into fully standard form? Who remembers how we finish it up? Lucas is almost done. We just have to multiply a little bit more. How do you multiply a trinomial and a binomial? We forget? No. What do you think, Dennis? You know something. Got to multiply this, 1, 2, 3, this trinomial by the binomial. Yeah, so each piece of the binomial by all 3 in the trinomial. So x times each of these, so what do we get? X to the third plus 4x squared plus 3x. So far, so good. That's just the x going in, right? And then now I'll do the negative 2. We get what? Negative 2x squared minus 8x, good, and minus 6. I just stack them above their like terms. Combine like terms. What do we get? X to the third plus 2x squared minus 5x. Good. So that is standard form. It is equivalent to factored form. They are the same. They just look different, right? So this is like saying 2 times 3 times 5. This is like saying 30. This step is like saying 6 times 5, right? They're all just different representations of the same thing. Now, if I know 2 times 3 times 5 is 30, could you tell me right away, without even doing anything, what 30 divided by 5 would be? Whatever the 2 times 3 is, exactly. And in this case, you know it's 6. And obviously, I think you guys know these anyway, right? So that's the example, this standard form, this factored form, that's all over these first few examples with long division. So, ready. I'm going to end this recording here, but start a new recording just so it's broken up. But what we're going to do here, we have factored form and standard form rewritten, and we're going to divide using long division this big thing by this little binomial right over here. So I'm just going to end this recording, and this is going to be continued in the next video.